module is going on, and in this video we will talk about the architecture of in-memory OLTP. This is the architecture of the SQL server, and this is a traditional architecture. And with this traditional architecture, a new component is added, which is the in-memory OLTP component. And in this component, there is the OLTP compiler and natively compiled stored procedure module, and there is the memory optimized table and memory optimized indexes, which can be a hash index or non-clustered index. There is no clustered index in memory optimized tables. And in this architecture of this in-memory OLTP, and there is another component which is a offline checkpoint thread, which is the part of this in-memory OLTP. And this thread is working as offline. At some point it will take the changes, either insertion, deletion, or updation, and it will write sequentially to these files. There is the memory optimized file group, which we have to create while creating the database. So we can create at the time of creating the database, or we can alter the database and we can add this memory optimized file group. This memory optimized file group is its base is the file stream file group, and it can be only one per database. File group can be created at a time of database creation, or later we can also add by using the alter statement. So now this architecture have the MDF file, LDF file, which are the traditional, and there is, if we are using the memory OLTP technology, then we have to add this memory optimized file group also. So now we will check the scenarios if the client is generating the request, how these requests are handled in this architecture. So we have the four scenarios. We will first generate the request to the disk based databases, which are the MDF files. In the MDF, we will know how this is executed, disk based request. Then we will generate the natively compiled request. Then we will create the this request of the in memory OLTP memory optimized tables, and at the end we will generate a request. In this request, both disk based and memory optimized table will be involved by the join query. So the first time the client is requesting the data from a disk table, the table name is disk sales table, and this disk sales tables client want the sales of 2019 years and the salesman name. So when the client will generate this request, the architecture will behave like this. So this request will go to the protocol layer, and through this protocol layer is communicating through the TDS packets. So these TDS packets will go to the CDM parser. CDM parser will generate will check the syntax and semantics, and will generate the query tree, and query optimizer will use this query tree to optimize the query plan, and then this query plan will go to the query in this interpreted TSQL query executor. And query executor with the help of access method will check that this query, what is the type of the query. If it is a select query, it will go to the buffer manager. If it is the other than select query, insert, update, it will go to the transaction manager. Now in our case, this is a select query. So this select query will go to the buffer manager. Buffer manager will check that the data is already in the plan cache or not. If not, it will go to the MDF file, and it will take the data and it will load the data into the cache. The buffer manager will keep the one copy in the cache, and then the result will be returned to the client. So this disk is involved. More disk input outputs will be involved. And if I will draw this one, it will be like this. So client generated the disk based request, and it will go to the protocol layer, then through the CDM parser, then optimizer, then interpreted TSQL. This access method will check this query type. Okay, this is a select query. Go to the buffer manager. Buffer manager will see the data is here or not. No, data is not here. So it will go to the MDF file. It will upload the data from here, and data one copies will kept here, and the result will be returned to the client. So this is a first scenario. Now we are going to the second scenario. Second scenario is this, that the natively compiled stored procedure. Client will request through the natively compiled store procedure. This is the natively compiled store procedure, and it has the instruction to insert into the memory optimized table the salesman name and it's the sales of the salesman. So it will add one value into this memory optimized table. So let's see how when this client will generate this execute this, to this procedure request, how the architecture will behave. So this request will go to the protocol layer. Of course, it will manipulate this one to the TDS packets, and this then after that this will go directly to the natively compiled store procedure. These are the store procedure which are already compiled. So this store, it will take that it will insert that data into the related table, memory optimized tables. So when this data is inserted into the memory optimized table, there is the offline checkpoint thread. It will execute at some point, and it will sequentially write the data into these files, this data file and data file, which is a pair of the files. And in SQL Server 2014 there is only these two files, data and data files. And but in later versions after SQL Server, there in SQL Server 2016 there is another introduced two files, which is a root file and the large data file. So now there are four files. This is in this memory optimized file group. And these checkpoint files, what they will do, these checkpoint files working in a pairs, data and delta files. So whenever there is the insert statement will come, this offline checkpoint thread will write the sequentially data into the data file. So it will write the sequentially and it will append the data into this data file. And if there is a delete instructions, it will go, the reference will be added into the delta file. So all the insertions are into the data file and all the deletions references are in the delta files. In 2014 there is only one checkpoint thread, and but after that there are multiple offline checkpoints threads are introduced into the SQL 2016 and later versions. So this is the process when the client will execute the in natively compiled stored procedures. So if I will want to draw, it will be like this. Client request came for the natively compiled store procedure. It will go to the protocol layer. It will make the TDS packets. In any case, the request will come to the protocol layers. After protocol layer, this will directly go to the natively compiled store procedures, which are already compiled. So there are no, these instructions will not be involved. So there are less instructions for execution is involved. So less CPU cycles will be involved. It will take the data from this from the it will the data is in this table, and the request is to insert the data into memory optimized table. That it will insert the data here, and this then the offline this checkpoint thread at some point will take these instructions insertions, and it will add sequentially to this file. And if there is any deletion, it will be added to the here. And after that, when there are this from some at some point, this data and files and delta files, which are used for the recovery purpose, also the data will be written to the LDF file also. So now in this memory OLTP there is MDF, LDF, and the memory optimized file group. And now we have talked just the second scenario, and we will see the third scenario. Now in the third scenario, the request is true for the memory optimized tables. So client will generate a request that client select mem.salesman and mem.sales from memory sales tables. So client will need the salesman and its sales from the memory optimized table. So this request for the memory optimized table, this is the request. So now this request we can implement in two ways. We can implement through the as usual TSQL statement, or we can use the natively compiled store procedure and we can write into this statement. So what will be the effects if we will use this way, or we can access this way? If we are accessing through the normal way TSQL statement, so what will be happened? then the request will go to the protocol layers. Then the protocol layer, it will go to the CRM parser, optimizer, interpreted TSQL executor, and then this interpreted TSQL will check, oh, this is a memory optimized table. This will request will be interpreted through the query interloop. Query inter operation will be responsible to take the data for the memory optimized table. And if this same request is generated by the memory optimized these procedures, natively compiled stored procedure, so what will be happened? And the same request for the data is now through the natively compiled stored procedure. It will go to the protocol layer, and then it will directly go to the natively compiled store procedure, which will take the data from the memory and will return to the client. So in this case, there is also the performance as compared to the disk based table. But if you are using the natively compiled store procedures, then the performance boost will be boost. So natively compiled store procedure is the best solution to access the memory optimized tables. And now, if we will discuss the fourth scenario. Fourth scenario is the uh, client is requesting the data both from the disk-based table and memory optimized table through the join query. So what is the client request? Client is generating the query. Select memory.salesman and memory.sales disk.sales 2019 from memory sales tables, and left join disk sales table on mem.salesman id is equal to disk.salesman id. So clients now want the data for the previous, which is on the disk, and the current data which is in the memory optimized tables. For both tables are involved. How this request will be entertained by the architecture? Request will go to the protocol layer, from the protocol to the CDM parser optimizer. Then it will go to the this normal interpreted TSQL executor. Normal TSQL executor will generate for the disk based. It will use the usual method which we will discuss in the scenario number one. And for the optimized memory optimized table, this it will connect with the contact with the query interoperation module, and query interoperation is responsible to take the data from memory optimized table. So now this query inter operation is fetching the data from this memory optimized file group and this disk based tables, and it's returning to the client after that. So in this scenario, when the both disk-based and memory optimized tables will be involved, then the architecture is working like this one, and query interoperation will also be involved.